Thank you, Jeff. Glad to be here with everybody. I wish we could do it in person. Going to do a technical update. Of course, it's myself, Sim and Donato again, as we have in the past. I'm going to talk a little bit about ASTM Committee's F6's actions recently, and also talk a little bit about a presentation that was actually on earlier today, but want to make sure you're aware of it and that you may want to make employees aware of, and that's what we called in situ relative humidity testing, friend or foe. So starting with ASTM Committee F6, just a quick review of the standards that are out there that affect your business and you should be aware of, and I would even recommend you likely have these in your library. First is ASTM F710-19. 2019 is the most recent version of this. It is a practice, and we added in this revision that it is the project design team's responsibility to determine the presence and quality and location of a below slab vapor retarder. Years ago, I asked you to sign a petition that I took to ASTM, which they really didn't like, but enough people got the message that it took years, but we finally gotten them to take the responsibility for learning about a subslab vapor retarder away from you, at least for existing structures, and place it with the design team, even though that hasn't really been defined. So with new construct, I would argue that you still need to ask and know whether there's a vapor retarder, what it is and at what elevation. But on remodel projects, you should be able to ask the design team what it is, where it is, so that you can rely on your moisture tests. F2170-19E, which was an editorial change. This is a test method. The biggest change we've made, of course, recently is taking the equilibration period down from 72 hours to 24 hours to read tests, and that has helped by encouraging more testing and being able to do it more quickly. F1869, most recent revision is 2016. The A was a second revision during that year. Nothing new since 2016 and nothing dramatic happened then. Again, a test method. Want to point out that 2659, which is the use of an impedance meter, is a guide. If you're using a meter, you might want to read that guide and see if you're doing it per some kind of a standard. F3010, which is our two-component mitigation system standard. Also recently, the MAT bond test, 3311-19. And a water droplet test for porosity, F3191-16. I've, in parentheses, put test method, guide, and practice onto this slide because test methods are things that you could be held legally liable for. If a manufacturer, and they all do, say test that concrete per F2170, it is imperative that that be done properly because it is a standard test method. Things that are practices or guides, there's a little more wiggle room, and a person can say, well, I didn't do it this way for this reason or that reason. A test method really needs a real good explanation, or it could get you in trouble. Also want to make you aware of some work items within F6. There are two work items that may affect you. The first is a standard guide for evaluation of comparative concrete substrate surface pH. That's a great name. We are trying to remove pH testing from F710. It never should have been there, and a number of us are trying to get it removed. However, there's a whole nother group that says, well, if you remove it, we've got to have some kind of test that we can use because we want to know about pH. And the reason that it came up with a title that says comparative concrete substrate, the principal author of the work that's being done, started studying reagent water. Now, reagent water is the water that's used in any ASTM standard or practice for any purpose. And reagent waters are any numbers of waters, but it includes the distilled water or deionized water that we would use for testing surface pH. And one of the things that was learned is that when water, especially distilled water, sits in a jug for any period of time, as frankly mine does on my shelf, if we test the pH of that water, it's no longer 7. Acid has formed in the water by reaction with carbon dioxide, and my water now is a pH of about 5.5. So what was attempted is to recognize that perhaps when we use water at a pH of 5.5 and read a 9, that pH was actually much higher. Now, that interlaboratory study is still going to happen to see if that's accurate or whether the strength of the alkali in concrete overpowers the very weak acid that was in the water. But just be aware that there's something being studied out there that may affect you. The other is a standard practice for fluid-applied membrane-forming moisture mitigation systems. And you might say, well, wait a minute, we already have F3010, and you're absolutely correct. This is an attempt for single component fluid-applied membranes. Not sure where it's going. There's a lot of resistance from a number of members of the committee, but it may be something that we will see in the future, and just want to make you aware of it. The other thing I want to make you aware of is, again, the idea of a presentation that's been recorded. It's available to you on your app. It's available, I believe it'll be available on the website through the forum. And that's a 30-minute presentation that I did on in situ relative humidity testing, calling it a friend or foe issue. And there are so many tests that are being done improperly. There are so many tests for which we are not gaining or gathering the background information that can affect the data that's being collected, that we've tried to put together at least a 30-minute presentation talking about those issues. I would highly recommend that whether you see it, anybody in your firm that either does testing or is responsible for reviewing testing would have a chance to look at that. So those are the things that are most important to me today. And something I guess I want to point out then on that in situ test, and it's also focused in that 30-minute presentation, that test came to us from Europe. Goran Hedenblad at the Lund University did the background work to develop an ability to monitor the drying of concrete. And that's all this test was intended to do. The test is intended for use on concrete that has high-quality vapor retarder directly below it, and it's intended to show us the approximate equilibration of moisture through the thickness of concrete once a floor covering is installed. It actually has nothing to do with concrete that's been re-wetted from the surface, has been re-wetted because dew point conditions were created in our workplace, has nothing to do with moisture coming up out of the earth at some later date. So we need to know that, and those are the things we need to be aware of when we're relying on in situ data. It was not intended for any of those conditions. That's not to say the data can't be used or be used for discussion, but it's not necessarily actionable just because we collected data. So with that, obviously, after all three of us have spoken, we're going to open it up to questions or comments. As always, I'm going to ask you to remember the forum and invite that emails and phone calls are always welcome, but the forum becomes a benefit to everyone. So with that, I'm going to hand this off to Sim Chrysler, who I think is going to talk about underlayments with recycled rubber.
Thank you, George. We appreciate it. Speaking of which, George and I, Donato, Lou Migliori, as well as Jennifer Fowler, are what I like to term the Fuse Alliance Technical Support Group. And basically, I continue to be amazed and impressed with the forum. I am tremendously grateful for the opportunity to be of service to the Fuse Alliance. Every day I'm on the forum, sometimes multiple times a day. Incidentally, no more than an hour and a half ago, I began a thread Lou and I did on the exact topic that I'm going to be speaking on today. This topic is basically one where I really feel, and I think George agrees and Donato agrees, that if we detect something, we determine there's something going on in the industry, we see a trend of issues, that it's up to us to, I guess, advise the Fuse membership about a potential problem that could be downstream, to hopefully do our due diligence and keep the Fuse Alliance members out of trouble. Now, again, I'm Sim Chrysler, and Specialty Flooring Solutions is my company. And today, the advisory that we're going to be doing is regarding the use of underlayments containing recycled or crumb rubber underneath PVC floor that contain phthalate plasticizers. Now, the idea for this topic, George and I have discussed it, Lou and I have discussed it. Each of us have seen a significant number of issues in the field where this has become an issue. And what we're going to deal with today is to talk a little bit about why it's an issue, what the scientific basis is for the issue, and what do we need to do about it? How do we need to handle it when we encounter this issue in the field? We have several active complaints going on, and these, like a lot of complaints, are catastrophic when they fail. It's not just a matter of getting a new pail of adhesive or 10 yards of new material of some sort. It's a massive failure of the entire project site, complete replacement, all the material, all the labor, all the ancillary costs, lost time, lost production, all of that happens. So let's move on. This advisory, this is based on hard science. Now, this science is provided by the raw material manufacturers that are involved here. This is crumb rubber. Now, what that is recycled rubber. Okay, now that is basically vehicle tires that have ended their useful life on the vehicle. They've been taken off, and there are millions and millions of them out there, and they are ground up and then fused together in a mat, and basically that is what the product that we're looking at is in this situation. Now, we're going to deal with the hard science that's provided by the rubber manufacturers, and as I've already mentioned, George and I and Lou have encountered quite a few issues of this sort, and Fuse Alliance members have been involved in some of these as well. And I just started a thread on this no more than 2 hours ago. So basically, we're going to start with that and move forward and hopefully get to the bottom of what the best way to handle this is. Now, these underlayments, the primary purpose of these things, the primary positioning that the manufacturers of these products have for these are to enhance the acoustic performance of the flooring system. With the marketplace in the last few years going away from the soft finishes, carpet basically is a sound deadener and a sound absorber, but now going more away from carpet to resilient sheet goods of various sorts, LVT, LVP, laminate, hardwood. All of those are a little bit more noisy, to lack of a better word. I guess that's a technical term. At any rate, what you're talking about here, to enhance the acoustic properties of your finished installation. There are a couple of ways this is measured. We'll just do a quick review. I bet most of you already know this. The two things you're really looking at on an interior installation are the IIC, that's the impact insulation class, and also the STC, that's the sound transmission class. Those ratings are numerical. Typically 50 is an average. When you get to 60, you're getting pretty good. You get above 60, you're really, really good. And I haven't seen very many in the 70s. None, as a matter of fact. Now, the IIC is kind of an interesting measurement device. It basically is a box that sits on the floor, and in that box are electrically activated hammers that beat on the floor. And when they do that, obviously they're simulating traffic, foot impact and what have you. And there is a sensor underneath the floor. And in the test apparatus that's set up in the lab, you can actually have any floor you want. 4 inches of concrete, you can have wood, whatever type of floor that you would want to have or might be involved in your actual project, you can have. And you measure the sound that is going, and it's basically going from the second floor of an apartment building to the first floor. So you're underneath listening to it with a sensing device. And the really key thing here is that you listen to it without the flooring and the underlayment in place, and then you listen to it again with it. And the change in that value, or the delta IIC, is really the value that tells you how much reduction in the transmission of sound from one floor to the next basically has happened. Now, the sound transmission class is really more about ambient noise in an area. This is tested by generating different frequencies of sound and measuring how much is actually measurable and what the level of measurement is in the actual building envelope where people are going to be sitting and working. It's more of a you're engineering these products to absorb sounds at certain frequencies that have proven to be, with the acoustic engineers have studied what is irritating to the human being when they're trying to work, and it tries to minimize those. But those two things are the main emphasis of why these crumb rubber underlayments have been created, at least the most current ones. Now, I've run into crumb rubber as a carpet pad, particularly for double stick. Oh, geez, it has been 30 years ago in Canada. I ran into this, and it was not being used under anything other than just broadloom with synthetic backing, or possibly a woven piece of broadloom, maybe an Axminster. So you had no PVC involved there. And the track record of that was not particularly good, but it's been around for a long time. And basically, it serves its purpose, and it does a good job acoustically with limiting and reducing these IIC and STC numbers to give you good values and acceptable values that the architects and the specifiers want. Now, there's one other one. It's OITC. That's outside to inside transmission class. These particular underlayment products don't play in that, although the crumb rubber industry does make sheets that go in walls. That's what this is really for, is to prevent sound from coming from the outside to the inside. They don't really play in that. That's not really, and that would never be exposed to the vinyl bearing floors that we're going to be discussing today. Now, why should we be concerned when we're using underlayments made from recycled rubber? You know, the last thing I want anybody to think is that I'm not a fan of recycling, repurposing, reusing. I absolutely am. But, you know, to use the word of one of our ex-presidents, Mr. Reagan said, trust but verify. But recycling is a two-edged sword. One thing I know from 33 years of working for a manufacturer and basically being directly involved in process control, in creating processes, in refining processes, that it doesn't matter how perfect your process is, how much work you've done on it, how magnificent and new your equipment is, it doesn't matter. If your raw material stream is inconsistent, you cannot convert that magically by your process to be a consistent finished product. So if you'll think about ground up tire, guys, it's basically anything from anywhere. So you don't know what you're getting when you do this. So you have an inherently unstable process and an unstable output from the process. Now, here we get down to the basic chemistry of all synthetic rubber used to make vehicle tires since World War II is styrene butadiene rubber, or simply SBR, as it's known in the trade. Now, I want to mention this here, and I'll mention this again. It's a well-known fact that SB rubber formulations, anything with an SBR rubber chemical backbone, are not compatible with the phthalate plasticizers found in almost all vinyl products. That's LVT, LVP, resilient sheet goods, any other PVC containing product has a potential issue when you put it in contact with a material made basically from recycled rubber, SBR rubber. Now, you say, that's nice of you to say, but what sort of proof do you have that this is a potential issue and it's becoming a real issue? Now, the main place that I went to get hard data on this, and I'm a big believer in hard data to support positions. Opinions don't really make much difference here. Where I looked was the people, you go to the source, you go to the people who made the rubber that went into these tires that are getting ground up and made into the underlayments that are going underneath our vinyl bearing products. The rubber manufacturers did. Now, what I did was I did screen caps on a few of what they call chemical resistance charts. Now, that's a pretty straightforward name. What that means is, and most of these guys make dozens of different kinds of rubber, but they take all of these rubbers, they expose them to a myriad, literally 200 or 300 different chemicals, and in each exposure, they rate what the performance is. How did the two interact? What did the chemical do to the rubber, and would the rubber still be suitable for use in its intended use, whatever that might be? So that's basically a chemical resistance chart. Now, if you look at these, in these about 200 chemicals in most of these charts, there are probably 8 or 10 chemicals that are in the phthalate family that are listed on these charts. Every single one of them, when exposed to SBR rubber, gives you at best an unsatisfactory result. Now, just to look at it specifically focused on fluoride, the most commonly tested phthalate that we know to be a plasticizer that is widely used is a compound. I promise I'm not going to go all chemical on it, okay? I am a chemist by education, but and a carpet installer by trade, but basically I'm not going to do that. But the compound we're talking about is bis-2-ethyl hexyl phthalate. And that big word is basically also known as DOP, like DOP a lot better than the other word. That's dioctyl phthalate. That's an 8-carbon alcohol that is esterified with something called phthalic anhydride. Okay, that's my chemistry lesson for the day. We'll do more of that later. Anyway, for consistency, what I used was I went to this chemical on each one of the charts and looked at what the results were when that chemical was exposed to SBR rubber. This is vulcanized SBR rubber. Vulcanization basically is the addition of sulfur at temperature with catalyst to the SBR rubber, makes it flexible, but it basically converts the rubber into a huge molecule with an almost infinite molecular weight. What it doesn't do is change how it reacts to these chemicals. Now, it's been understood for many years. I can remember back, in the mid-70s, the company I was working for, Milliken, basically was coming out with vinyl-backed carpet tile. And we struggled to find an adhesive that would work and make carpet tile work like we wanted. We being Milliken wanted carpet tile to work in the way we were selling it, which is that you can install it. It doesn't move laterally, but yet you can grab it and peel it up off the floor and put it back without applying more adhesive as many times as you want to, as long as the adhesive stays clean. Well, SBR-based rubber chemistries were very much available at that time, and you can make those into an adhesive that starts out with those properties, no problem. But after about 3 months, the adhesive has turned to goo, basically. What you have is something that instead of being an adhesive, which is, last time I checked, supposed to prevent movement, this becomes a lubricant and it facilitates movement, which is just a bad situation when you've got carpet tile that are slipping and sliding every time you step on it. So basically, we had to rework and look at the chemistry again. But it's well known and well understood the adhesives that we use, these SBR adhesives, are commonly known as multi-purpose or general purpose flooring adhesives. We're all familiar with them. If you look at every pail of it, in big letters on there somewhere, it says not for use with vinyl. So, these adhesives are strictly prohibited to be used for the installation of any PVC containing floor. That's another hard science fact that supports the fact that you have a potential issue when you put these two things, LVT or LVP, any vinyl bearing floor, in contact with a crumb rubber underlayment. Okay, here's a couple of the screen caps that I got, and just so you don't think I'm making this up or I Photoshop this somehow. I know you're used to seeing links to the internet in blue. I got creative. I put these in red. So down at the bottom here, if you click on this link, if you get this presentation, then it will be available to you from the Fuse people, the IT people. You click on this link, it's going to take you to this chemical resistance chart. Mica rubber has been around for 30 or 40 years. Basically, here's dioctylphthalate. That's our friend, the plasticizer. Was a very commonly used plasticizer. Not so much today, but it's chemically basically identical to what's being used today. You look at SBR rubber, and we got 4, which means unsatisfactory. Well, that would tell me that it's probably not a really good idea to put together something that can release the phthalate like this onto SBR rubber. Now, here's my favorite, Martin's rubber. Now, these cats have been in business since 1865 and piddling around making rubber. It's a long, long time. Now, everybody else's charts use what I'll affectionately call weasel words, okay? Unsatisfactory, not recommended. These guys, they don't mince any word. They simply say, if they don't like it, they say, do not use. You can look down here, when you get an X rating with these guys, it means don't use it. Don't get our SBR rubber anywhere close to phthalate-based plasticizers. Now, I apologize. This is the best I could do with the screen cap. Here's the link again, the red down at the bottom. But if you look at the very bottom of the chart, you can see dioctylphthalate, DOP. If you go all the way across, you see SBR is actually the third column from the right side, but you can see it is an X. It's a do not use SBR rubber where you're going to have dioctylphthalate involved in the process. Now, all right, here's the granddaddy, Firestone rubber. Firestone's kind of like Kleenex and Coca-Cola. That's known for rubber. Now, they don't call it DOP. What they call it is di-2-ethyl hexyl phthalate, which is a synonym. The chemical industry, the chemical naming, it's an outfit called IUPAC, International Union of Pure and Applied Chemistry. I think they make these things up. We get these names as complicated as they can, and you've got 20 different names for exactly the same compound. This is a synonym for dioctylphthalate, and it's rated an X by Firestone, which they call not recommended. So again, that's pretty clear to me that they're not supporting the use of their SBR rubber in any contact with DOP, or what they call it, diethyl hexyl phthalate. That's, again, they're just synonyms. Now, here's one from Custom Advanced Connections. They're not tied to any specific rubber manufacturer, but they serve the rubber manufacturing industry with these chemical resistance charts. This one was real easy to use. This is kind of like chemical resistance charts for dummies. Basically, you pull it up. Here's the link down at the bottom. You pull it up. You type in the chemical that you're looking for. You select from the list the rubber that you want to compare it with or expose it to, and you hit search, and boom, doesn't even give you anything. It just gives you a color code. You don't have to even be able to read to know what it is. Red means, and you can see it's red, not recommended. So again, every single one of these I've looked at, about a dozen so far, every phthalate, every one of them receives a not recommended, do not use, unsatisfactory rating when exposed to SBR rubber. So basically, that's just not a good idea. Now, Additionally, we mentioned this already. Additionally, George and I and Lou have all got quite a few of these things that are out there, end users, and some involve user alliance members. These things blow up on you, and again, it's not just a matter of getting an extra roll of the underlayment or an extra pail of adhesive somewhere. You have a situation where you at the very least have lost the installation, and you've lost the underlayment product. You have to do something different. May or may not lose the LVT or the LVP or the vinyl sheet goods or whatever vinyl material, could be vinyl carpet type for all that. Basically, you haven't necessarily lost that, but the probability is pretty good you've lost that. And you've certainly lost all of the furniture movement, all of the ancillary costs, all of the costs when they start suing everybody about lost time and lost productivity. This can be just a massive, massive amount of money that it can cost. We've actually seen these things out there, so we are very, very much behind that. If you do run into this, we want to talk about what do you do. Now, you're installing any PVC floor, the vast majority of which contains phthalate-based plasticizer. This plasticizer, it will leach out of the flooring into whatever you put it on top of. PVC plasticizers, these phthalate-based plasticizers, are not covalently bonded to the PVC matrix. They're in there as a mixture. They soften the mix, make it so it's a useful material, but they seek equilibrium with their environment, which is a diffusionary process, and basically they leach out of the backing. This is not something you cause, this is just something that happens. And what you got to be careful with PVC is that what it comes in contact with can stand some plasticizer leaching into it and not have its properties change. And as you can see from the chemical resistance charge, that's not the case with SBR rubber. Now, it will come out and it will go into whatever it's on top of. And if whatever it's on top of is not glad to see it and reacts badly to it, then you get into some of these issues. Now, a lot of floors these days, I think Interface has got some other people, some LVT that has non-phthalate plasticizers. Now, these guys are based on a chemical called terephthalic acid. Okay, now they are very, very chemically similar to the phthalate-based plasticizers. The old classic plasticizers are called orthophthalates, if anybody ever asked. But the terephthalic acid ones are made from a different chemical starting point, but they wind up being virtually identical to the phthalate-based plasticizers, the orthophthalic-based plasticizers. The reason they moved to those is, you may remember a couple of years ago, there was a big scare with children, 1 and 2 year olds, who, because of putting plastic toys in their mouth, and that's what babies do, they get something that goes right in their mouth. Basically, they were showing up with plasticizer with phthalates detectable in their bloodstream. Now, it's known and it's tasked. It's on the REACH list, if you're familiar with that, in the European Union. It's on the EPA hit list in several places, California in particular, for both reproductive toxicity and also it's called teratogenic toxicity, which means it can cause cell mutations. So, and that's in very high concentrations, but it's not really in danger. But the non-phthalate plasticizers don't have the regulatory issues that the phthalate-based plasticizers, the orthophthalic-based plasticizers have. Now, so there's no reason to think. Now, I can't show you a paper that says they've taken, it would be 2-ethyl hexyl terephthalates, but they've taken that and exposed it to SBR rubber. I don't have any reason to suspect, and there's nothing chemically to tell me that they wouldn't do exactly the same thing that the orthophthalate would do. But the good news is you don't have to deal with the regulatory issues when you use these. It may just be because they haven't gotten around to testing. I don't know. Now, you find, and this is key, you find your company being tasked to install a recycled crumb rubber underlayment under any PVC containing floor. Express serious concern and demand written assurance that the manufacturer understands the issue and is willing to warrant their product for this use. Now, if you get into this situation, and you've got questions and questions are being fired at you, get on the forum. Put these questions in, post them. I promise you, George and I and Lou will be back to you with an answer very quickly, and we'll get you to where you want to be. And basically, hopefully, you can get this thing handled before you actually have to install it. But if you do have to install it, you need to make sure all these questions are answered, and it never hurts to do it exactly the way they say do it. They're going to guarantee you that it'll work, even though the chemistry and the science says it won't. They're going to do that. I would have somebody on site from the manufacturer of the underlayment, probably the manufacturer of the flooring product as well. Make sure you do it exactly right on the initial day or two of install, and that way you've got a benchmark. If things go south on you, you've got something to go back to say, well, this was done right. This is not my problem. This is your problem. And that's, basically to protect yourself. Now, George and I and Lou, basically, if you're going to have a project that's going to require sound deadening, and that's more and more common as we get more and more hard surface type floorings as opposed to soft floorings onto installations and on the project. Strongly recommend that what you do is select an LVT or an LVP that has an integral sound deadening layer as part of it. Let the manufacturer of that product be responsible for hearing it and for installing it and for the compatibility between that layer and the actual vinyl flooring itself. That way it takes the responsibility off you. All you have to do is get it down to the floor, and the rest of the stuff will be handled by the manufacturer one. Now, understand this, and this is extremely important, extremely important. This caveat applies only to the installation of these materials over PVC containing flooring. Not impugning this stuff. It makes a wonderful sound deadening thing if the material itself is dimensionally stable and has good planar stability. In other words, doesn't get bigger, doesn't get smaller, doesn't curl, doesn't dome, doesn't just go crazy moving around. If it's stable, it under hardwood, engineered wood, under laminate, anything that doesn't contain PVC, I think it would do a wonderful job of deadening the acoustic properties of the floor. But again, it's just not a good idea to use it if you have a PVC containing floor. So basically, take that away. If you have questions, please get on the forum, ask us, and we will feed back to you as quickly as we possibly can and give you the questions to ask, help you with any kind of documentation you might need to basically protect yourself. So basically, guys, listen, I really appreciate your attention. I appreciate your time. And, at this point, I'm going to pass it off to Donato, and we'll go from there. And there will be a question and answer period at the end of all three presentations and after Donato's presentation. And we'll all be here live to answer any questions that you have, and look forward to it. Boy, I surely do hope that next year, I'm kind of, you can tell by the hair, I'm kind of into George Burns things, so I don't necessarily even buy green bananas anymore. But man, I hope I make it to next year and can see all of you face to face, handshake, maybe even a hug. I really miss it because I'm old school about this kind of thing. But kudos to the technical staff. I'm talking about the IT staff for Fuse to make what looks to be just an absolutely jam up virtual meeting just as good as it could possibly be without actually being able to meet face to face. Thanks a lot for your attention again. We'll talk to you soon. I'm passing it on to Donato. Thank you.
Thank you, Sim. This is Donato Pompo with Ceramic Tile and Stone Consultants and the University of Ceramic Tile and Stone. As you may know, that I'm the expert who's retained by Fuse Alliance to consult with their members regarding tile and stone applications. Ceramic Tile and Stone Consultants, I am the president of that company. We do forensic investigations. We do architectural installation specifications. We perform testing, and we perform quality control services for projects to oversee the work. And also we do hands-on training for installation of tile and stone. I'm also the president of the University of Ceramic Tile and Stone, where we provide online training programs from a sales point of view to actual technical and installation training. Today, I'm going to talk about several different things, giving you our annual Tile and Stone update. First of all, I'm going to talk about the COVID-19 pandemic effect on the tile industry economy. Going to talk about some of the industry standards and give you an update on that. Going to talk about some new tile trends and let you know what's the latest in that area. I'm going to talk quite a bit about avoiding problems in wet areas with slope control being such a key factor. And I'll get into details on that. I've got a few case studies to kind of emphasize the things that can go wrong and also how to prevent problems with tile installations in wet applications. And then we'll briefly talk about continued education, the University of Ceramic Tile and Stone online training, to see if we can encourage Fuse members to take advantage of this opportunity that Fuse has provided for their members. So ceramic tile consumption has dropped this up through September of 2020. Consumption dropped 11.6%. Obviously, a big factor there is the COVID pandemic. Also, the tariffs on China were a factor that I'll point out. Imports fell 15.8%, and again, due to COVID and to the China tariffs. USA production dropped only 1.5%. And why that's so good is because of the China tariffs that took place, where China lost a significant portion of what they were exporting into the U.S. And the U.S. Plants, which we have quite a few tile manufacturing plants in the United States now, they took up that slack that China lost. So Spain is actually our biggest importer who took over for China. China is actually down 98% from what they were in 2019. Commercial floor covering purchases declined 6.2% in 2020. Outlook-wise, things look good for 2021. Because of the low interest rates and because of the COVID-19 vaccine. So hopefully we'll be getting back to normal to some degree. Estimated increase is estimated at 3.7%. Commercial markets could continue to lose ground, mainly because of the diminishing commercial work in terms of funds, investments into commercial buildings. And part of that is because of COVID and the fact that more people are working remotely from home. And for some companies, that's working out quite well, where they don't see the need for having the building space that they've had in the past. Here's a good example of the consumption in terms of imports, or at least what was imported into the U.S. from other countries. I mean, look here. You can see here on China. I mean, you notice at one point in 2018, they had almost 32% of the imports was from China, and now they're down to less than 1%. Here you can see Spain has continued to rise, and again, see Spain and Turkey and Mexico and the U.S. Are increasing because of making up the slack for that. But one thing to keep in mind is that for instance, Italy, who is kind of somewhat flat, but even though they're about third in terms of imports, in terms of dollars, they're actually the top importer for dollars. They've got about 32% of the imports in terms of dollars, and that's because the average cost per square foot of their products is about $2 per square foot landed, where the other products is about $1 per square foot. So some new tile and stone building codes. 2021 International Building Code has some changes regarding tile. The new adhered porcelain exterior veneer tile size limitations has substantially increased, up to 9 square feet for traditional thickness tiles. So that's like a 3-foot by 3-foot tile or some rectangular equivalent. And for the thin gauge porcelain tiles, it's 17.5 square feet. They're much thinner, lighter, and that's, about 3 feet by 5 feet, a little bit more than that in terms of sizes and other square and rectangular sizes. Now, previously, just last year, the limitation was 3 square feet for porcelain tiles, and before that, it was 5 square feet. So it's significantly more, and that's because we have the products to help ensure a good installation. Of course, if they're installed correctly, that's always a key factor. New ANSI A108.20 exterior thin gauge porcelain tile standard has been released. That's for exterior applications of the thin gauge porcelain tile versus A108.19 was for interior applications. And of course, we have the ANSI A137.3 that is the manufacturing and performance standards for the thin gauge porcelain tiles. Another thing that the ANSI committee is working on right now is standards for 2 centimeter, which is 3/4 of an inch or thicker tiles, to set standards for that, because that's becoming much more dominant in the market. It's a size that is catching on for various applications. New ASTMC 1823 shear bond strength test of adhered stone. Industry standard building code is based on shear bond. Industry standards are based on shear bond, but it's always been a difficult test to do. And over 10 years ago, I created a test protocol and the apparatus for doing shear bond testing, particularly on exterior veneers, but it can be used on floor applications and other applications. So now it's an ASTM standard. And it can be used not only for investigating failures, but it's also for quality assurance. So if you want to make sure that that the installation is being installed and performing the way it's intended, it's a test that during new construction can be performed. Gauge porcelain tile panels trend update. I've shown you this before. These thin tile panels are taking more market share as it continues to increase significantly. There's a lot of benefits here. First of all, they use inkjet technology where they can replicate pretty much any kind of stone or wood surface or anything else. That's pretty amazing. Also, they have they're now producing these panels and in 3-foot by 5-foot pieces that are 3/4 of an inch or thicker. So that now it can be used for countertops, and they can be fabricated within a fabrication shop that normally is fabricating natural stone for counters. So this is an opportunity for contractors, because there's a lot of guys out there doing this work, and to do it, you're getting paid a whole lot more and you have less competition. But it requires that you have the proper tools and the proper training in order to be able to install this type of a product, since it's so different than your traditional tiles. UCTS online course, the tile installer thin set verification course, teaches how to install this product. We have a very extensive section on how to install this in wall applications as well as floor applications, and it has some extensive video and animations demonstrating how it should be installed. So this is a must for any installer who's going to be installing this product, that they have their installers go through this 5-hour online course to make sure they understand what the standards are and how to properly install it. Here's, pointed out that the 2 centimeter, which is 3/4 of an inch porcelain tile, is is taking off in a big way. One is the pedestal system. Pedestal systems is not something new. They've been around for a while, but traditionally, you're using 2-inch thick precast concrete or 2-inch or thicker natural stone for pedestal systems. Now with the dense porcelain tiles at 3/4 of an inch, you can use those over a pedestal system if done correctly. The benefit is that you can have a level surface to walk on, and for an exterior application, you would have the underlying substrate that has drains and the proper slope to drain and the waterproofing. And then you don't grout the tiles. The water just drains through the tile joints down below. Also, it's easy for repairs where you can, if you need to provide maintenance to your drains, you can easily pull these up and replace them. But again, just like any other kind of installation, it has to be done properly. Otherwise, you can have potential problems. Another way they're promoting this product is for landscaping pavers. Now, these can be installed over a sand bed or even direct on the ground in some cases. If it's done correctly, sand bed installations have been around for a while, but you got to have a drainage plane. You got to compact the sand. You got to properly install these to make sure they work well. But one of the benefits of this thickness of product, even for commercial applications, is that it's much more resistant to damage. So when the tile isn't installed correctly, so often or sometimes you have excessive voids under the tile that result in cracked corners and other damages. Well, the thicker material is a little more forgiving, even though we still recommend getting that 95% contact when you're adhering them. So here showing you is what we recommend for the 2 centimeter porcelain tiles or natural stone, is that you use this type of a system over a grate that you have. So you have the surface to help support the tile, so that you're not only getting the pedestals, which you can see in there. You can see that you got this tray. They refer to it as a tray as well. So here's the tray. It has the pedestals underneath, and you can take a look and see they're there. But there again, pedestal systems kind of look easy to install, but it's very critical on how they're installed, particularly when you have a slope underneath, or if you have an unstable substrate, it can be problematic. But if you're going to install the 2 centimeter porcelains or other stones, you definitely should be using one of these tray systems. Underlying substrate must have a slope in interior wet and exterior applications. I've talked to you guys before about this. This is really critical. We see a lot of problems of improper design of substrates, particularly in wet areas such as a shower or an exterior deck application. You can see that what's critical is that you've got to have, there's several things. Number one is the underlying substrate has to be pre-sloped, because the problem is that if the surface where the waterproof membrane is located isn't sloped properly and it isn't designed so water can evacuate, then it gets trapped and it's then subjecting the tile or stone to continuous moisture. And in addition to that, we always recommend putting the membrane on top of the mortar bed and bonding the tile to it, because that keeps the moisture out of the mortar bed, which can retain a lot of moisture that can lead to problems. So the common deficiencies that we find during our investigations: inadequate slope at the membrane, and I'll be showing you a case study where that has occurred. weep holes plugged at a drain. That's critical. That you got to have the membrane sloped to the drain, and then you got to have weep hole protection so that the water can readily evacuate. Moisture staining in the natural stone and tiles, slabs. I mean, that's one of the big issues that can come up. And the rust color staining in a natural stone can occur when it's subjected to excessive moisture due to the natural occurring minerals that a natural stone contains. So here's a case study. It's a project right on the ocean in a bay area. This is like a $30 million plus home under construction. We were hired to do some limited quality control, and then later had us come in when they were having problems to investigate their problem, and it was staining. And if you look here, you can see in this area you got this brownish yellowish staining that occurred. Now this is a travertine. It's I think it's like 2 foot by 5 foot pieces. It's 3 centimeter thick. That's 1.25 inches. And it's a travertine with unfilled travertine, meaning the within the surface of the stone that you've got open voids, which is natural for travertine because travertine is developed through precipitation of calcium carbonate in hot springs over millions of years. And most of the time when you see travertines, they're filled, those pores, particularly for floor applications. So here you can see how horrendous this is, getting this kind of staining. So, we did investigate. We removed some stones. We saw that they used a thin set adhesive to bond to a plaster substrate, actually to a membrane over a plaster substrate. And they had some mechanical anchors attached to it as well. And the stone had a resin backing. So, it didn't seem anyway that the moisture would have been migrating from the back to the surface. So we ended up doing some laboratory testing. I mean, we found that this staining occurred not only exterior, but also on the interior of the house. So when we did our laboratory testing, we found that in these unfilled voids, through the natural development of the process, it developed a bacteria that resided in these voids. That was a manganese bacteria, and it was a soluble manganese, meaning that it would dissolve in water. So here they are right on the water, and moisture condensation. Well, that organic manganese is invisible, so you can't really see it. But as it migrated to the surface of the stone and was subjected to the elements, and being on a saltwater location, it oxidized, which converted the soluble manganese to insoluble, which the insoluble has this coloring. So actually, right now, we're in the process of trying to remove it. We know that phosphoric acid does remove it to a degree, but it has reoccurred. So it's a project that we're currently still investigating. So here's a project in Beverly Hills, California, a very high-end residence. They put this beautiful Portuguese limestone in and got all this staining, and we're concerned about it. We were brought in to investigate, well, why did this occur? So first of all, we discover that we do a moisture survey, and we see that on the moisture meter, you see it's painted. I mean, it just, high content of moisture. So that was a symptom of the problem that we were trying to find. We started doing some destructive testing, and one of the things that I always say is that when there's a problem, it's never due to one deficiency. generally speaking, it's due to multiple compounding deficiencies that leads to a failure. So here you can see you got over 5 inches of mortar bed here, and plus the mortar bed was had a high content of sand to cement, and was very porous, and so that becomes like a sponge. It absorbs moisture. The next thing that was wrong is they had this Ditra uncoupling system there. Well, Ditra uncoupling is designed for the tile to bond directly to it, not to be under a mortar bed. And Ditra actually has a drain mat, so it would have been more logical if it was a drain mat where it would have a covering over the plastic so water could then drain readily away as long as it had somewhere to drain to, which in this case, it doesn't. Now, it also acts as a moisture barrier, so it doesn't allow any moisture from the mortar bed to get away. And plus, Ditra doesn't recommend this as a waterproof membrane. It actually needs an additional waterproof membrane to perform correctly. But anyway, it should have never been used in this application. So then we remove the mortar bed down to the drain, and we find that the weep holes were plugged. They had no weep hole protection. You know, there's plastic covers that you put on it, or you put down pea gravel or something. And then we look further and find out that the slope to the drain is not to the drain; it's away from the drain. So another compounding factor that has led to this whole assembly retaining moisture and subjecting the limestone to constant moisture that resulted in that condition. Next is a project that we worked on where it was a big commercial project. We first came in because they had an exterior veneer problem with this slate material on this building that was about 6 stories high. But one of the things was that they had these 3 decks, and they were saying the problem was that one is that they had these bird baths throughout, and then they also had water flooding into the building. So they called us in because they did not want to have to tear up all the concrete and redo it. So we came up with some ideas on how to deal with it. This was about 6,000 square feet of an exterior colored concrete deck, 3 different levels. Problems were flooding into the building, as I said, and bird baths because there wasn't an adequate slope to the drains. And the remediation was to remove the concrete to a depth to allow us for an adequate slope to the various area drains, which were kind of in a inconsistent location. So it was a real complex challenge having us to figure this out. And this is what I'm going to show you how we did figure it out. And to upgrade the look, they wanted to use a ceramic tile, so we used 12 by 24 slip-resistant porcelain tiles. And again, we were the quality control specifier, provided the oversight, had a full-time one of our inspectors on the job managing the process. And what we did is that we chipped it down and then had a polymer modified mortar over it with a waterproof membrane in the tile. So here you can see in one of the bird baths, if you can see that, it's level. Well, it's not supposed to be level, it's supposed to be sloped to the drain. So what do we have to do? We had to create a very complex map, looking at all the drain positions. We had to do a topography survey, figure out what were the existing slopes, how deep would we have to go in order to achieve in the ideal was 1/4 inch per foot, but in some cases that was just not possible. So we created these little patterns indicating how deep we had to go in different areas in order to achieve the overall slope that we needed to achieve for it to properly slope. One of the things that threw a monkey wrench into things was that, normally rebar is at the bottom of the concrete or suspended about a third of the way up. But here it was down about 1.5 inches. We ran into a rebar. And so that became a problem. So we had to like grind below the rebar and bend some of it down to get it to a depth so that once our mortar bed and everything's over it, we have at least 1 inch covering it, because that's what's required according to ACI standards, is that in order to keep it from corroding, you need to have at least 1 inch thick of mortar or concrete over the top of it. So the ones that were exposed, we had to treat it according to the manufacturer's recommendations for the high strength mortar, treat it with their thin set mortar to coat it. So again, that helps it make it not be susceptible to corrosion. So one of the creative things that we did, because you can see here we have existing control joints, expansion joints, and the concrete that we had to honor. We had all these different angles and everything. And so we actually, if you can see it here, we've got screws that are laid out right here. And in these screws, we were using them to establish the slope, both to make sure we had a precise slope that with very little variance, because in some cases we just didn't have the 1/4 inch per foot that we wanted, and we had to make sure it was precise with very little variance. Plus, it was helping being more productive, because our guy could go ahead and establish the slope and then have guys behind it coming in and doing the screeds. And they could do it a lot faster. So here's a sample of the screw with the string that we laid out in order to establish the slopes. And again, we had a very complex situation where we had all these different angles that we had to maneuver around. And again, you can see here where we have the drain here, and we created a circle with the screws to establish the screed that we needed to achieve. Here again, you can see we got screws laid in all different angles. Again, it was a real challenge making sure that we took everything into consideration, because we had different things we couldn't adjust, such as the planters, doorways, other things. So what we did is, after we put the screeds in, we actually had we were removing the screws afterwards, which later we ended up leaving them in because they're corrosion resistant screws. And plus we could treat them with the thin set, and it was going to be more problematic taking them out rather than leaving them in. So here we put in our perimeter screeds. This is where we use a dry pack mortar to establish those so we could screed off of them. And again, in order to have an accurate slope that was continuous within plane. Here, one of the things I wanted to point out, notice along the perimeter here, we have some foam is what I mean. So we use concrete form foam. And we do that because all perimeters are supposed to have a movement joint. So this is an easy way, fast way to establish a movement joint along perimeters. You use this foam and you can lay it out. And even it's perforated. So in some cases where once you get the tile up or whatever, you can rip off a section of it to get it at the level that you want it to be at. So here you see we're filling in between the screeds. Notice what this guy's doing here. We're putting down our slurry bond coat. That's very critical. This is the thin set that's mixed up a little wetter that we apply over it while it's still tacky, and then we start floating the mortar over that. Here you can see they're screeding off. Again, you can see the screeds that we have here, and then we use the straight edge to screed in order to get a consistent slope within plane. So here you can see some completed areas where you can see all the screeds that we had and how we know that we're going to have a perfect slope for setting the tile over. Next is a waterproof crack isolation membrane. Now this is important because this is where I was saying earlier, if you put the waterproof membrane on top of the mortar bed, keep the water out of the mortar bed, then there's no reservoir of water. So any water that gets in the thin set evaporates pretty quickly and can't cause a problem. So here you see the waterproof membrane. The lighter color means it's fresh, it hasn't dried. The darker is shows that it has dried. So it's required 2 coats. Here we're using a gauge that you should be doing as you apply it to make sure that it is applied at the proper thickness. Once it's dried to the touch, you can actually bond to it or apply the second coat. Now for flood testing, you got to let it dry a lot longer. So notice here that we're honoring the existing movement joints in the substrate, and we take the reinforcement fabric and loop it in and then paint over it. So we have a continuous waterproof membrane. Here we're setting the tile. Key step is using the flat side of the trowel to burn or key it into the back of the tile as well as the substrate. Here you want to trowel, so your trowel ridges are all parallel to each other. On larger tiles, we want to trowel parallel to the short edge of the tile because we don't want to trap air underneath. And that's what that helps you do. Plus, when you're setting the tile, you set it and you shift it perpendicular to the trowel ridges. That way the ridges collapse into the valleys, and that's how you get full contact. And you can see here you got thin set oozing up along the corners. That's a good sign. Of course, you got to scrape that out while it's fresh and before you set the next tile to make sure it's an open joint. Here is what it looks like when you install it correctly. You pull it up, and that's what we do. And we do a job like this, or we're pulling up these tiles to make sure we've got adequate coverage. In some applications, you can maybe not do every tile. Exterior veneers, we do it literally every tile. People think that it might slow them down, but actually when you have a systematic process, they can actually be more productive. So if you pull it up, you don't want to see any trowel ridges underneath there. If you do, then you add more thin set and put it right back down. So you pull it right away while it's fresh and easy to replace. So moving joints is always critical in all installations. People tend to avoid them, thinking they're going to, cause a aesthetically bad look. So what we did is, the standard is every 8 to 12 feet. So what we did is we created a grid pattern with a basket weave pattern with the tile. And so every 4 feet, we created a 1/4 inch joint for our generic movement joints, and to just kind of accentuate the pattern. So you can be creative to get it to blend in where it doesn't become an eyesore. And here's where we honored some joints, and you can see that both these are the underlying expansion joints and the concrete from different sections. Here you can see, you can't hardly tell that you have a movement joint there. Here's completed installation. You can see that, you really don't, the expansion joints are not a problem. I mean, it really blends in. It looks great. So it's something that shouldn't be avoided. It should always be incorporated because quite often it can lead to problems if you don't have them. Here again is the installation, completed installation. They're just cleaning it there, doing some power washing. Came out what great. Owner, general contractor, everybody just loved it. And it drained perfectly. So update on continued education. I told you last year that we have the new online course, Complete Guide on Developing Tile and Stone Specifications with Architects. It provides the student with a thorough and detailed process on architectural sales, how architectural sales representatives can get their tile and stone products specified with bulletproof specifications, meaning it's resistant to value engineering and substitutions. Of course, covers the selection process of the tile or stone for the intended use, make sure it's suitable. Types of art, goes through the types of architectural specifications, goes through the master format structure and how to do the part 1, 2, and part 3 format. Talks about how to get your product specified and interact with the architect and specifiers, and talks about strategy in terms of tracking and protecting a specification. And it has a really nice section, thorough section on communication skills that can be used for any type of communication in terms of adjusting your personality with somebody else's and how to best effectively communicate with somebody. So don't forget to train your installers. We've told you this over the last few years. Fuse made a big investment on getting these tuitions for the U of CTS online courses. One of the ones that I think is in your best interest to utilize is the Tile Installer Thinset Standards Verification course. It teaches industry standards and practices for thin setting all types of tile. It's taught in both English and Spanish. It teaches substrate inspection, how to properly prepare a substrate, thin set coverage, how do you get full contact, and it gives various quality control steps throughout the process to ensure you're getting the results that you need to get. Also teaches how to install shower pans, steam rooms, gauge porcelain tile panel installations, glass tile, and grouting of various types of grouts. And it prevents costly problems and gives you credibility. I mean, if you can go in and say that my installers are ITS verified, they've gone through the training through the University of Ceramic Tile and Stone, it might be the difference between you getting a job and not getting a job. Plus, it sends out a message that you're quality minded and the work that you do, you want to make sure is done well. And plus, it's going to save you a lot of money from avoiding potential problems. Right now, Fuse is offering a special deal. If you purchase 3 of the tuitions for $100, they'll give you the 4th one free. So that brings the cost down to $75 each. I mean, this is a cheap investment that will give you an ongoing return on that investment over time. Are there any questions?